so what I want to do, today we're going to do the Pythagorean theorem day one. And some of you remember, some of you don't. I'm going to do a quick refresher on Pythagorean's theorem. I will tell you, however, something. Yes, ma'am. What? Okay. So I will tell you, though, something to be cautious about as you go into high school. They do not generally reteach you anything. They assume when you get there, you know what you're supposed to know, which basically would mean the entirety of Algebra 1 and everything before it. Okay? Multiplying fractions, dividing fractions, slope intercept, all the things that you're supposed to learn in Algebra 1, they are going to assume you know. Factoring. So make certain that you're actually retaining the information. So Pythagoras, who is the dude who invented the Pythagorean theorem, discovered that there was a mathematical relationship between the sides of any right triangle. Every right triangle ever in the history of the world has a relationship between the three sides, mathematically speaking. And there are actually three, so we know there are three sides to a right triangle, and they each have a name. This is a leg, and this is called the hypotenuse. Okay? So you have two legs and a hypotenuse. The hypotenuse is always the longest side. It's always found by finding the right angle, and it always points to the hypotenuse. The right angle always points to the hypotenuse. Okay? What Pythagoras discovered is if you take the length of the leg, and you square it, and you add it to the square of the other leg, then they will always equal the hypotenuse squared. Or more specifically, if you label them sides A, B, and C, with C always being the hypotenuse, then A squared plus B squared has to equal C squared. That's Pythagorean theorem. It works every time, no matter what, doesn't matter, always works. If you find that A squared plus B squared, or the two legs squared and added together, equals the hypotenuse squared, by definition you have a right triangle. It's almost like a proof. It's a way to prove that you have a right triangle. Now, when I taught this in 8th grade and my 6th grade compacted group, I gave them 4 steps to follow for every Pythagorean theorem problem. Here are the 4 steps. The very first thing you do is you find C. It is the first step. It is the first thing you must do. The easiest way to find C is to go to the right angle. That's the opposite. Then you label A and C. A and B. A and B. Okay? It doesn't matter which one is A and which one is B, by the way. So, in number 1, let's see, we use the right angle, draws an arrow, that means that's C. Then we make this A and this B. That's step 1. Step 2, fill in the Pythagorean theorem. That's where we simply fill in the numbers that we have. So let's see, we have A squared, we don't know what it is, so let's say it's A squared, plus B squared, that's 3.6 squared, equals C squared, that's 7.4 squared. A squared plus B squared equals C squared, right? Okay, now, what I would recommend you go ahead and do is go ahead and do 3.6 squared and 7.4 squared. And get real numbers for those. Ooh, that's not right. So we end up with A squared plus 12.96 equals 7.4 squared, 54.76. Right? So let's see, I've done this step, I've done this step. Next step is to isolate my variable. How do I isolate my variable mathematically? Subtract 12.96. Subtract 12.96 from both sides. And I get A squared equals 41.8. Adios, muchachos. Thank you.
Yeah. Oh, wait, are you videoing this?
What?
Are you videoing this?
I'm recording it, yes. Nope, too late. Yes.
Isn't it like
What?
the right okay, like it's triangle and then like the right
A and B are both always on the right. Because C is the opposite. Well, yes, baby, that's what I just went over. Yes. Okay. Okay, so yes, sir.
Will this only work for right triangles?
Yes. It only works with like lines. Okay? And your very last step, once you are done, is to find the square root and solve. So what you basically do is you take the square root of both sides. What's the square root of a squared? A. And then the square root of 41.8, you simply go into your calculator. Clear, second 41.8. Whoops, here. Second root 41.8, hit enter, and you get 6.5. Rounded to the tenths. Okay? And that's how you solve the Pythagorean theorem. Okay? Any questions on that? Seriously, I'm about to put you up. Okay? Any questions on that? So let's do this. Let me get rid of all that, because hopefully you have those steps, because those steps are really importante. So here we go. Let's finish the rest of this. Erase. You gonna work? Okay, so let's go through our steps really quickly. Which one in number 2 is C?
9.9.
9.9. That's the first step. And then you just label A and B. So then we fill in. So we end up with 6.5 squared plus B squared equals 9.9 squared. Again, we go through that process of 6.5 squared is 42.25 plus B squared equals 98.01. We subtract 42.25, and we end up with B squared equals, whoops, that's not what I want, minus 1.25, and we end up 6.476. And what is always the last step? Square root. Square root, square root. Second root 6.476 equals 7.5. B equals 7.5. Good to go? It's better whenever you're looking for C. Like on number 3, here's our right angle. That means this is C, which makes this A and B. So this actually becomes pretty easy. 7 squared, bless you, plus 2 squared equals C squared. 7 squared is 49, 2 squared is 4, 53 equals C squared. So all you really have to do is take the square root of 53, and you get C equals 7.3. And finally, simplified radical. So again, we find C. There it is. So we end up with 6 squared plus 3 squared equals C squared. 36 plus 9, which is 45, equals C squared. Square root, square root. Now, last few days, we've been simplifying radicals. What's the split on the square root of 45? Good square root, bad square root. 9 and 5. So the square root of 45 becomes the square root of 9, square root of 5. Square root of 9 becomes 3 root 5, and that is the value of C. Any questions on that? It is. Now, what you need to pay attention to is sometimes I'm going to ask you to round it to the tenths. Sometimes I'm going to ask you to do it in simplified radical form. But it should be okay either way. So I would like you to please do number 1. Do number 1, leave it in simplified radical form. And then I'll do number 2 because it gets a little bit tricky.
You checking in for D?
Yeah. Couple more medals for this competition. These kids win. Five root 10. Any questions on that?
How'd you do that?
Well, did everyone get 250 equals C squared?
Yes.
Okay. How do you split the square root of 250 into good square root, bad square root? 25 times 10. 25 times 10 is 250. 25 is a good square root. So you end up with square root of 25, square root of 10. The square root of 25 is 5. You end up with 5 root 10. Good. Guys, you're going to find a lot of these things that we're doing in geometry really require that you slow down. Slow down. Take your time. Okay? All right, so now let's look at number 2. I want you to kind of watch this so you kind of get this. So again, we go through the steps. Steps are still to find C first, then we label A and B. And then we fill in Pythagorean's theorem, which gives us 4 squared plus x squared equals 2 root 5 squared. Now you notice I put 2 root 5 in parentheses before I wrote it as squared. And I'm going to show you why you need to do that. So, hey, please, you're wrong, A, and B, if you'll listen more, you'll learn. Got it? So we go 4 squared, which is 16, plus x squared, we don't know what that is, but now we get this guy. Now here's what I would recommend you do. Anything squared is just anything times itself, agreed? Okay, so here's what I would suggest you do. Now the short answer is, if you wanted to, you could do this in the calculator. The better answer is, it's fine if you do it in the calculator for geometry, but then you're going to get to algebra 2, you're going to have tests with no calculator, so you better know how to do it without a calculator. So that's what I'm going to show you today. So 2 root 5 squared is really the same as 2 times the square root of 5 times 2 times the square root of 5. It's 2 root 5 times itself. So here's what you do. Yesterday we learned how to do root 5 times root 5. What is that? It's 5. And what is 2 times 2? And what is 5 times 4? And that's what it is. 2 root 5 times 2 root 5 is 20. Now, you won't be able to do that in your head right away. Eventually you will. But for right now, I would do this, where you write 2 root 5, 2 root 5, and you connect the numbers, you connect the roots, and then you multiply what you have left. And it'll be a quick, easy way to get where you're going. Now, we have a pretty straightforward Pythagorean theorem problem. We subtract 16 from both sides, which gives us x squared equals 4, which means x equals 2, because we square root both sides. So x equals 2. Make sense? So I'd like for you to try 3, por favor. I want you to try 3, following all the steps, including that little trick I just showed you on how to do a number times a root squared. Remember, follow those steps. Finding C, labeling A and B, plugging them in, isolating the variable, and the square root at the end. Make sure you got to a point where you have 48 equals the x squared. Then we take the square root. The square root of 48 split to the square root of 16 times the square root of 3, which is 4 times the square root of 3. And that is the value of your x. It is. Well, you just have to follow the steps. It's a lot of work.
It would only be like a 2%.
So, show your steps. Okay. Try number 5 yourself. Step number 5 yourself, please. Show every step, or I will count it wrong. Yes, yes, please. Number 5.
Yeah, I just
I'll do 4 real quick. C, so 6 squared plus x squared equals 532 squared. 36 plus x squared, no. 50. No. And when you take the square root of 14, it stays as the square root of 14 because neither 4 nor 9 go into the even. You can't split it.
Oh, I forgot that it was the number plus one.
The number of guys, that has to be your first step. First step is find C. Every time, find C. Okay? Any questions on either of these? Okay, so on your classwork, you have a front and a back. You have the front, which is all like the triangles, and the back, which is all the word problems. Get back into the habit of doing that. Tomorrow we're going to kind of dial it up a little bit, so I need you back solid on Pythagorean theorem. This is all, except for the radical part, this is all like 8th grade stuff that you should have had last year. Okay, you should have Pythagorean theorem last year. So do the classwork. The answer keys are out. They are blue. Then you are done.